so as I mentioned before, we're covering geometric figures, and these are all of the things that you need to know how to do. These are all the things that you're going to need to know how to do. So the first one on our list is scale factor. Now, for some stupid reason, mathematicians use the letter K to mean scale factor. God knows why, but anyway, when you're trying to calculate scale factor, you put your second shape over the first shape. So you just read them like a book. You read from left to right. So this is my first shape. This is my second shape. And I'm trying to calculate the scale factor, so I pick any side. So what am I putting on the top?
8
Great. 8 would go over 2. So what would be my scale factor? How many 2's go into 8? 4. Cool. So K equals 4. I could test it with my other side as well. Oh, sorry, that should be 4. Okay, so what's my other side? Let's do it with the other missing side that I haven't done so far. Great, so 16 over 4. How many 4's go into 16? 4. So it has a scale factor of 4. Awesome. Your second shape always goes over your first shape. Even if your second shape is smaller than the first, it doesn't matter. Second always goes on top, first on the bottom. Any questions about scale factor? Yes?
You always have to do it with both matching sides.
Yeah, you can just do it with one. If one is enough for you to find scale factor, generally that's all you have to do. I just did it with both just so you can see that it works with both. Okay, now what we want to do is use scale factor to find missing sides. So let's do our rectangular examples first. Here I've got both measurements. Here I've only got one measurement and an unknown. So what do you think I'm trying to find? X. Great. I'm trying to find what x equals. So the way I do it is I need to find out what the scale factor is for the sides that I'm given. So here. So what goes on top?
18 over
awesome.
3.
So it'll be 18 over 3, which equals 6. So what that means is this has been multiplied by 6 to give this.
Awesome.
So therefore, what am I going to be doing there?
2 times 6.
Times 6. Fantastic. So x is going to be equal to
12.
12. Oops, equals 12. So our first step is to find the two sides that we're given, and I'm putting my second shape on top of my first. 3 goes into 18 6 times, so that means it has a scale factor of 6. So what that means is this side has been multiplied by 6 to give this. So if this side has been multiplied by 6, this side is also multiplied by 6 because the shape's been enlarged by the same amount. So 2 times 6 gives me 12. Now I want to do the same with my triangles here. I'm given 2 sides. I'm given 2 sides on my second shape, but I'm only given one and an unknown mystery side on this first shape. So how do I calculate the scale factor? Peter?
Divide 10 by 5. I mean, sorry. You see how many 5s go?
Okay, if I'm calculating scale factor, which shape goes on top? Second or first? Second. So what number goes on the top? 5. Over 10 is equal to?
2.
Yeah, 1 over 2. So it's been halved. So this number has been halved. Great. So it's been halved. So, yep. So, ooh, okay, to go in the opposite direction, I need to double it. Yeah? So this has been halved. So if I were going from here to here, it's been halved. But what's the opposite of halving? Doubling. So this, I'm going to do the opposite. If that makes it too difficult going in 2 different directions, look at it like this. That's been multiplied by 2. So that's been multiplied by 2. Does that make more sense if you're going in the same direction?
Yeah.
Cool. So to go from here to here, you've multiplied by 2. Here to here, you've multiplied by 2. So x is going to be 3 times 2 equals 6. Cool. So what I want to do is I want to write a proof that's 4 lines, so I need 3 individual lines matching one another, and then I need a final statement at the very end giving a reason. So anyway, let's start with this side. What's this side called?
BC.
And what is it equal to on the other triangle?
DE.
And how do I know that?
Because it's given.
It's given. Great, it tells me. It's got a little dash on there telling me they're the same. Alright, what about this here? What do I call this angle?
Acute.
Yep, it is cute, but no, I'm just going to call it angle C. Is equal to
Angle E, D, F.
angle D. And how do I know that?
Because it's given.
It's given. So this is a side. You don't have to do this, but I like labeling so I know what letters to which proof I'm using. Okay, and then what's my last piece of information? What's my last matching piece?
AB.
So AB. AC.
Oh, I was.
AC is equal to
DF.
DF. And how do I know that?
It was just given.
It's given. And what letter is that?
S.
S. So what type of proof have I used here? SAS.
Therefore,
Triangle
ABC is equal to DEF.
Now, when we're doing congruent, we do 3 lines across. 3 lines across means congruent. Congruent to triangle DEF. And the reason is SAS. Coolsies. So you'll notice on here I have 1 line explaining what's matching, a 2nd line explaining what's matching, 3rd line explaining what's matching, and then a reason. Therefore, this triangle is congruent to this triangle with my reason. So with my type of proof. And your 5 proofs are SSS, SAS, ASA, AAS, and RHS. Alright, let's do another congruence proof. Now, I'm out to prove that those 2 triangles that are like fused together, that they're congruent to one another. So, do I have 3 pieces of information here that I can talk about?
Right. Yes.
Yes? Alright, so what's my first one? Okay, so which type of proof do you think I might be looking at? Ella just yells it out. RHS, because it's got a right angle, it's got a hypotenuse, and a shared side. So, let's talk about my right angle. What do I call?
and then is equal to NMO.
So when you are talking about an angle that is shared, I can't just say angle M, I have to use the 2 arms and put the M in the middle, because if I just say angle M, I'd be talking about the whole thing. So I want to just talk about this side here. So I use the 2 arms, so it's called LMO. So LMO is equal to NMO, and how do I know that?
Because it's given.
Given. Cool. Alright, I'm going to run that out just so it doesn't confuse you when we're working. Alright, so that's my right angle. Next up, I need a H. I need to do my hypotenuse. And how do I know that? Cool, and then what's last?
MO equals MO.
Great. MO is equal to MO, and it's shared.
Sorry, MP is N.
So that's R, that's H, and that's S. There's another word that you'll come across for shared. Sometimes they use the word common. Common just means shared. Like
Do
it's,
you get marked down if you don't say common?
but if you ever come across a question where it says, what is the common side? It just common's another word, shared. Okay, what am I missing?
Conclusion.
Therefore, great, I need my concluding statement. Therefore, triangle
LMO
Congruent NMO
more complicated because all of the sides aren't given to us. Yeah, alright. So, any ideas as to what I might start talking about, which proof I might use? Okay, so angle, side, where's my other angle?
Doesn't triangle
Angle, side.
angles the same?
You start from the border to the top.
Not necessarily.
Angle, side, angle.
They could be, but it's not given to me that they are.
Angle,
You
side,
have
angle.
to, you have to use those ones.
Angle, side.
What are they? Does anyone remember what these two were called?
The cube.
Starts with a V. 2 words. V. Vertically.
Opposite.
Yeah, they're vertically opposite.
What was it? Vertically what?
Vertically opposite. Great. So that's the most difficult part. We just realized that they're the same because they're vertically opposite. Cool. So I've got an angle, and a side. So AAS.
I told you it was AAS.
So let's talk about these ones first. Oh, hang on, I haven't got it.
C-H-O-I-C-S.
Alright, sorry. Now let's talk about our vertically opposite angles. So what's this one called here?
Angle,
What's
side.
the top side called? How do I label it? What letters do I use? Do I call it
H-I-J.
So if I say
Oh no, J-I-H.
J-I-H means I'm talking about this one. How do I talk about this one?
I-J-H.
Great. So I-J-H angle is equal to
K-J-L.
awesome. And how do I know that?
Given.
No.
It's vertically opposite.
Vertically opposite, and that's an angle. It's an angle. Cool. Alright, so I'm using AAS. So next I talk about
K.
Angle.
angle.
K.
K-J.
Talk about top one first.
H.
I.
I-J. I equals,
So if there's no other lines coming off that angle, you can just use one letter to talk about it. Like if I say angle K, there's no confusion about what angle I'm talking about, it's only this one. Whereas if I said angle J, there are technically 4 angles coming off J. So you only need to use 3 letters if there's going to be some sort of confusion. Alright, so K, and that's given, and that's an A. And then lastly, what am I going to be talking about?
J-H.
HI is equal to KL, and it's given. And that's an S. What do I need next? Anyone? What am I needing to do next? I can't stop there.
Therefore, triangle.
H-I-J
J.
is congruent to triangle J-L-K. And I'm using AAS. So now let's talk about similar proofs. Now these are quite similar to congruence proofs, but what's different between congruent and similar? So similar triangles have been enlarged or shrunk down, so they're not identical. What we're doing is we're doing similar proofs. They're different to congruence because it's when the shape has been shrunk or enlarged. So here I've got angle A is equal to angle Y, angle C is equal to angle X, because it's got the dashes. And then that just means that angle B is equal to angle Z. Therefore, triangle ABC, instead of 3 dashes sideways like this for congruence, I'm going to be doing 3 up and down. That means similar. Similar to triangle XYZ. Now, my reasoning. Oh, sorry, I keep forgetting. Given. That's given. Given. And what's my reasoning? AAA. 3 angles that I'm comparing. Now I have two triangles. The second one has been shrunk down, and these ones involve numbers.
Is that SAS?
Yep, spot on. I need to figure out firstly what? Before I can get started with my proof, I need to calculate the
Scale factor.
awesome. I need to find out if they are actually similar. So how do you go from 5 to 10?
Times 2.
How do you go from 4 to 8?
Times 2.
Great. So do they have the same scale factor?
Yes.
Yes, they do. Awesome. So now I can do my proof. So IJ is equal to
MN.
MN. And what's the reason? It's not given.
It's vertically.
Divided by 2. In my ratio.
Proof given. What if it doesn't times 2?
If they're not by the same number, then they're not similar triangles.
So you
So
don't
you've got to have dual proof. Everyone in your exam, if you're supposed to do a proof for it, it will work out. Okay. All right. So in ratio, what's the next thing I'm doing? So that's an S.
J equals LM
It doesn't have to
in
be hard, I just gotta
ratio.
get it back.
So HJ is equal to LM, and my reason is in ratio. And that's an S, but what am I missing in the middle?
Angle J equals angle M.
Angle J is equal to angle M. And what's my reasoning for that one?
Given.
Given. That's an A.
It's not only straight.
What do I do next?
Therefore, triangle IJH is similar to the triangle MNL. Yes, or element. Wait, it doesn't matter the order of the letters, right?